So hello, good morning everyone. So today, me myself, Vaishnav Srivastava, and my colleague Amish Srivastava, we will be presenting a code camp session on MLOps and Azure ML. So MLOps is nothing but machine learning operations. So here in this session, we will be looking into how we can completely streamline our machine learning process and lifecycle, and then how we can integrate it with continuous integration and continuous development using the Azure platform, so that we can easily uh, manage our services, our whole life cycle, and our deployment and everything else. So moving on to our next slide. So that will be covering our agenda. So for the agenda for today, we will be looking into, at first we'll be looking into the introduction to MLOps. What is MLOps and why are we using it? Then we will be starting also from the basics, like what is software engineering and the difference between this, the difference between software engineering and machine learning. And we'll be looking into why machine learning is used and a simple architecture of how the code works in both of these. Then we'll be looking into what is MLOps, basically machine learning operations, and how it helps us in achieving and streamlining our whole process. Then we'll be looking into the CI/CD, what is CI/CD pipeline, and the architecture of it for the code that we are going to develop. Then we'll be briefly looking into what are the other platforms or some platforms that are supporting MLOps for machine learning projects. Then we'll be moving on to an overview of Azure ML. What is Azure ML? As like the introduction to Azure ML. And then we'll be covering some of the features, mainly the features that we will be utilizing. And then after covering that, we will be moving towards the benefits of Azure ML for MLOps, how like what are the challenges that it helps us facing resolve, and how our end-to-end solution completely works. And then in the end, after we have deployed our whole solution, how we can monitor and optimize our own solution and continuously develop on it. Then after that, we'll be looking into finally the deployment part, like how we are going to achieve the MLOps with Azure ML, where we'll be deploying our own model. We'll be showing you that in at first using the theoretical part, then we'll be covering it in the demo part. Then we will be also giving you the architecture of how it completely works and some of the benefits of the GitHub action that we'll be utilizing to streamline this process. Then finally, last but not the least, then we'll be covering our best practices and recommendations that people should consider. And then finally, we will be having our demo that will be presented by Aman, and then we'll be having a quick basically doubt session. So yeah. So moving on to the next slide. What is the main difference between software engineering and machine learning? So as Arthur L. Samuel, a famous mathematician, said that the machine learning is nothing but the ability of a computer or an algorithm to learn from some of the data that we provided as an input, right, without being explicitly programmed. So we basically provided some data and then we are expecting some predictions. So we are not like hard coding it something, or like we are not providing certain logic that it will perform certain way, but it is inherently learning from its own, from the data that we provided. So as you can see below in the below diagram, that we will be providing it with a training input, and we will be also providing it with the expected output. So what will happen is that based on those two answers, we will be providing it with a question and a solution. So based on that, we will be doing our ML training, basically machine learning training, and our model, we will be developing a machine learning model. That so using those, it will be able to predict whatever if a certain type of input is provided in the future. So as you can see in the later part of when we have built our model logic and we have built our model, we will be having a basically an inference point that you can simply refer to as an endpoint, where we'll be providing an input, and then we will be expecting a prediction or expecting output. It could be classification, it could be anything, right? Then, so there are some of the main differences between software engineering and machine learning. So by definition, like we are developing software systems, and then in machine learning, we are merely learning from the data for predictions. The main objective for software engineering is we are building reliable software, right? And but the main goal of machine learning is that we are trying to create predictive models that will help us solve some real life problems. And then one of the main activities that requires that we need to perform is I think it is common in both, that the requirement gathering, and then we will be mainly focusing on the coding part in the software engineering side of things. And then the coding part will be the majority of the part that will be covered in the software engineering side, and then finally will be testing. But in machine learning, the majority of the work goes into the data processing and the model training pipelines, where we will be processing the data because the raw data that we do get is needs to be optimized, and it's very noisy. So we need to we need to get the data cleaned, and so that our model can train perfectly, and we get basically a good accuracy on our model. So the skill sets that are required for software engineering are basically, you should know programming and design, right? But for machine learning, it's a bit different. We do require mathematics a lot because we will be utilizing that, and programming. And then finally, some knowledge and some basic knowledge and some more advanced knowledge about ML algorithms, depending upon whatever solution or the project that you're trying to implement. So the main emphasis on in the software engineering part is the functional software that we are going to build. But on the machine learning side, we are mainly emphasizing on the data patterns that we have and the model accuracy that we are going to achieve. So some of the metrics by which we are going to measure the software engineering side of things is using the is basically having a performance metrics, and either having a user satisfaction the survey or like things. So by that we will be evaluating our software. But in machine learning, we will be mainly utilizing accuracy and precision, how well our model performs, how well our model is able to predict things, right? There are also other metrics, but like we will be mainly focusing on these things. Then finally, like some of the applications that we can develop is that, like for software engineering, using software engineering is mobile apps, web application, and in using machine learning, we can develop like image recognition, virtual assistants like chatbots, and basically NLP model. So there are a lot of things that both of these like platforms can achieve, right? And now let's completely look at and quickly cover our software engineering architecture diagram. So it's basically simple. We are providing some input, and we will be giving it some logic, and then we'll be writing our logic, we'll be writing our code, and then we are expecting a certain output that should come from the result. And it is completely different from the machine learning side of things. So as you can see. Now moving on to the next slide, and start with the introduction of MLOps. So basically, what is MLOps? So basically, it is a set of practices where we are combining machine learning and DevOps to automate and streamline the ML lifecycle. So it is nothing but we are combining the MLOps operation and the DevOps operation. And so some of the core components in the MLOps lifecycle, it involves like model development and continuous integration, continuous deployment. They are like self-explanatory, right? And then monitoring and governance finally. So after like you have achieved continuous integration and deployment, you will need to monitor the model and then maybe retrain it, and then continuously develop and upgrade the model, and then also the governance part. So when we do apply MLOps and we have a completely productionized system, basically what you call it a production ready system, it helps us it helps us to bridge the gap between data scientists and RT operations team. It basically alleviates the problem of collaboration, that we can have multiple collaboration, multiple people can collaborate. Then it automates the workflows for model training, testing, and deployment. So, and also because we will be using our basically Azure ML platform, so it will also help us in the scaling part of things. And then it also ensures that the consistent versioning of the model and the data is there, and the code is basically reproducible. Now the other part is like after we have done the deployment and everything, we need to monitor the model. We need to continuously model the performance metrics, whether the accuracy is dropping, whether the accuracy is dropping, whether the model is not performing well, whether we can improve it. So we can also monitor in this. Now, the other thing comes as scalability and governance, where the Azure MLOps, and when we are trying to achieve MLOps using Azure, it supports the scalable deployment and the management of ML models in various environments that we want. And so one of the other things, that is one of the more important things that will be provided by Azure itself, is going to be the compliance, security, and the accountability for it. So like it does provide inbuilt security features. So we will look more into that in basically the future slides. So some of the benefits of it, of using MLOps and like deploying and streamlining the whole workflow, is that it enhances the efficiency, it reduces the time to market, and it improves the reliability of our ML solutions that we are going to provide. Now, so MLOps comes in like multiple levels, as you can see. So you can call it basically stages in a way. So first is our manual process where we are just where we are building the model, we are deploying the model even manually, and then so basically that thing because we are building the model, we are deploying the model manually. It basically results in infrequent releases, and it basically lacks our CI/CD pipeline. We are like we are not doing the CI/CD anyway in this in this process, and then it because of that it causes a gap between ML and the operation side of things, right? It is not very streamlined. Then the second would be that we are uh, will be basically ML pipeline automation, where we are trying to automate the ML pipeline for continuous model training and delivery. We are still not doing the continuous deployment. We are still not doing the continuous integration part of things. We are just automating the process of building the model and then basically deploying it, right? Just that part. So mainly what this does is it emphasizes us to train new data, to train new pipelines and then test it. So but finally then when we combine these things and then we combine the whole process and we also integrate the CI/CD pipeline automation into it, we get like what we get is the full package where we are basically able to test our new algorithms, new models. So while we are also handling user needs and we have deployed our model, we can orchestrate like multiple experiments to, and we can also push multiple codes or multiple modification to our code to a repository, which will automatically trigger the build pipelines, and then we can test it, and then we can keep basically building on top of the project that we are already building, right? So now let's look into what is CI/CD pipeline. So CI/CD is nothing but it is very simple. It is basically continuous integration, continuous development. I'm pretty sure each one of you basically doesn't want me to explain the meaning of that because it is self-explanatory. Now we goes like what does MLOps help us do? It basically MLOps integrates the ML deployment and the ML development part and the maintenance part in the same structure. Basically, it streamlines the whole process, and it automates the task of managing version and it also basically encourages collaboration and the scalable deployments, right? Using that. And MLOps also enables CI/CD pipelines for swift model iteration and deployments, as we said, right? So basically, whenever if we think that the accuracy is dropping, we can have multiple checks on it. We can continuously monitor our model performance, and then we can continuously develop our model, trying to improve it, and then we can push new things on it. So basically, it also helps us in achieving that. It also prioritizes the monitoring, logging, and the performance tracking for the reliability, as I said earlier, right? And and it also helps us to encourage teamwork among data scientists and engineers and operations because all the process is very streamlined and it's automated. So now the main part that the data scientists and the engineers and the operations teams can mainly work on the can mainly work on basically the development part of the things, right? And then we can ensure that the latest and the greatest code and the model is being pushed, and the user is getting the best results, right? It also ensures basically reproducibility and governance in ML workflows for compliance and the best practices, right? So the CI/CD pipeline, the whole structure, like the whole flow, comes into like three phases where we will be at first we will be doing development and the planning part, where we'll be defining our problems, we'll be planning, we'll be doing our data collection part, then the preparation part, then will be our model deployment and the version control that we will be establishing how we are going to achieve that. Then comes the continuous integration and the continuous deployment part where we'll be deploying our models. Then finally after we have deployed our models and we have established those things, we can monitor our model and manage our systems, where we can basically integrate different logging systems to it, and then we can monitor our models, and we can also monitor our model using the different performance metrics that we have, and and we can also have establish a feedback loop that if the accuracy or if something falls below certain level, then we can continuously trigger model update or basically re-trigger those pipeline, right? And the scaling part and the resource management part will be also handled by the Azure part, right? So as you will see in the future slides. So this is what our whole CI/CD pipeline architecture will look like. What we are going to be achieving. So this is just an overview of the thing. So we will be having a GitHub repository where we will be having our source code, which will be configured where we'll be pushing our code. Then as soon as the code is committed, we will be having a Docker image build, and then we will be also running our test and validation part. And then finally, after our Docker is built, we will be pushing that Docker into our ACR. ACR is nothing but Azure Container Registry, which we will learn more about in future slides. And then which will store our whole application in the containerized image format. And then finally, we will be making an Azure web instance where we'll be deploying that image so that so that user can take the input as an endpoint, and then we can basically return results from it, right? And so this process is going to be fully streamlined. So now if suppose some user basically commits another thing, and we have modified our model, we have modified more training data, we have improved the accuracy from suppose 90% to 95%, then as soon as we trigger another commit, is we are going to automatically build the whole pipeline, build the whole structure. So you see how it is going to help us in achieving like all these things and streamlining these things, right? Now, moving on to some of the platforms and the tools that are supported that support MLOps and that are used for MLOps is one of the platforms that I'm pretty sure a lot of you would have heard of is Kubeflow. Uh, basically, Kubeflow helps us in like ML workflow management on Kubernetes. And then there are other like free to use tools which are such as MLflow. So it also helps us in making like end-to-end ML lifecycle platforms. Then we have DVC, which helps us in like the version controls for ML project. Then we also have like Metaflow. Metaflow is just a Python library which also helps us in achieving the MLOps, and also it provides us multiple libraries that helps us in data science projects. Then Apache Airflow, it also helps us in machine learning orchestration, along with many other things that also helps us achieve. Then we have last but not the least is like certain core, where we can where basically it helps us to deploy our machine learning models on Kubernetes side of things. Now we come to the main three big giants that we are going to utilize is basically Amazon SageMaker. So Amazon SageMaker is just a machine learning platform or service that is provided by our AWS, and where we can achieve these things similar to Azure. And then for the GCP side of things, we have the Google ML suite, where we can achieve MLOps, and we can train the models. We can have the full completely do the full production of a machine learning lifecycle in the basically Google Cloud platform, right? And then finally, the one that we are going to be implementing is the Microsoft Azure ML. So where will we be completely building our cloud-based ML lifecycle as a service, right? So these are some tools that we can utilize. Now moving on to the overview of Azure ML. So just doing like a quick introduction on the Azure ML. So Azure ML basically offers us multiple tools building training and deploying our machine learning models. It integrates with the Microsoft uh, basically Microsoft other Azure services, and it's very streamlined, like easily. And it also helps us in like achieving basically streamlined workflows. It also supports like AutoML if AutoML and easy model creation. It has like multiple features such as Canvas. So it is also really good for like if the people who wants to prefer and try to train the model with low code to no code, and also who are learning. It provides and of course it provides the MLOps capabilities for managing the ML lifecycle. It auto offers the basically our scalable infrastructure for ML experimentation. Suppose if we want to scale our infrastructure, we can scale it on the go, and also it also supports like auto scaling features. And the other thing is that it of course enables the collaboration and the version controls, and with basically the built-in features that it has available. So ultimately, it simplifies the whole AI development process, and by giving us pre-built models, giving us multiple pipelines, giving us other features that we can utilize to basically ease our way and completely deliver our solution. And ultimately, it basically empowers our business to harness the AI, and develop multiple solutions for multiple use cases, and that we can deploy and use efficiently. So some of the Azure features, as I've covered some of them earlier, is that it has like a pre-trained model repository, which will help us in diversifying multiple ML tasks. So if the user wants to train a new model, it's also super good um, uh, for learning purposes, because it has the whole model training. So if you want to go check it out, you can easily simply check it out. Then the security and the compliance training, it has built-in security features and compliance certification and IAM tools for robust protection. It also supports like the native popular frameworks that we use for machine learning, is like TensorFlow and PyTorch. It has seamless Azure cloud platform integration with basically other Azure services. It provides like quick it basically provides quick prototyping, and we can use we can use transfer learning to speed up our development. Then last but not the least, it enables the resource management and the enterprise, because we can make our whole project more scalable. And then finally, it because we are making things more scalable, and then finally we are implementing MLOps. So it also encourages the collaboration between among teams. Now, moving on to some of the Azure ML features that we will be looking into is that are most important is model registry. So model registry is nothing but a centralized model repository for storing and versioning and managing ML models. It basically facilitates our organization where we are going to track the multiple models, and going to we are going to update the model, so we can look at multiple models, multiple versions of it, and we can deploy the best of it, right? So, and it also enables us to suppose we can give a certain user some permissions, and then they will also be able to access those models and utilize those models and see and deploy also those models. Yeah. So one of the least but not the least, last but not the least features is online and batch prediction. So where if we want to have some real-time prediction and basically real-time inference setup, we can use that. So basically, the Azure Web App service helps us in achieving that, and then it also provides like low latency predictions on the live data side of things, and it also handles like batch predictions, which are like bulk predictions. Suppose if you're not time constraint, and then you can give like multiple files and multiple inputs, and then it can also process the large inputs easily. Then here we are going to be looking at some of the benefits of using then here we are going to basically looking into some of the benefits of using Azure ML for MLOps. So one of the main things is that before covering the benefits, there are a lot of challenges that we face. Is that if you are not using Azure, if you are using multiple platforms, multiple things, and if you are doing things manually, it increases the complexity of our things, and it also causes issues of a smooth integration across different stages. Suppose we are using multiple platforms basically if you're using multiple platforms in achieving the MLOps side of things. So what Azure ML helps us in that it provides us just one platform where we'll be able to achieve and access all those services that we require. And the scale, and one of the other issues is the scale is basically the scalability concerns. So as the demand grows, whether or not we will be able to scale our product or scale our solution or not. Then the customization part. So customization part is easily resolved by the CI/CD part. We can easily customize our whole solution. Then finally, last but not the least, is the consistency and the dependency management. So we are not dependent on like multiple platforms, multiple solutions. We are just sticking to one platform, which will provide us which will provide us all the solutions, all the requirements that we need, and then we can basically uh, deliver our successful solution. So our whole end-to-end solution kind of looks like this, that we are going to simplify our implementation, and then we are going to improve our integration part of things, because we are just utilizing Azure ML. And then in turn, it is going to reduce the complexity of the things that we are going because we are using just one or two platforms. We are going to be using two platforms, right? Just GitHub and our Azure ML. Then because it has built-in security features, it also helps us in improving the security and also improving the security and maintaining the security, and eventually making it more robust. And finally, because it can auto scale, and so we can scale it down, we can scale the things down, we can scale the things up. It also helps us in efficiently reducing the cost. So instead of using multiple platforms, we are just sticking to one platform. So basically these are the things that will be mainly considered in our end-to-end solution. Now, moving on to the next slide, which is about monitoring and optimization, I will like to hand it over to my colleague Aman Srivastava, which will tell you more about optimizations and the deployment side of things. Aman.
Yeah, thank you so much, Darius, for covering up this part. Just let me share my screen. I hope it is visible to all of you.
Yeah, it is.
So, continuing with our session, let's talk about monitoring and optimization. So, we can easily understand with our words that are self-explanatory. Talking about this aspect, let's say, what about the model performance metrics? It is very important that we keep a track of our model performance, that whenever it is deployed, it is working in a production. So we should be aware that how our model is performing over there. Are we getting desired results or not? Is it satisfactory to the user or not? So for that particular thing in the performance metrics, we use these kinds of metrics like precision, accuracy, recall, FN score. These are some ML accuracy metrics that helps you identify the performance of your model. Moving on, the resource utilization. Of course, it is very essential that we keep in check the whatever the resources we are utilizing for our solution. Either it can be a CPU or GPU, whatever the resources. That depends on the solution, that how heavy it is, how many users it is serving at a time. So that increases our cost depending upon the resources. So that we also have to keep in check. As in talking about the data drift detection, let's say we have trained our model on a certain data, and over a period of time, our model is handling some new data that it has never seen. So there might be an issue occur that model may not be able to perform so well over that. So in that case, we will be logging about the data drift detection, so that we can identify, yeah, model needs to retrain again, and we need to rerun the whole process to update our model. As in the model drift detection, so what happens in the model drift detection, it detects the deviation in the model prediction. Suppose you wanted a model to predict something, and it is not actually giving those particular outcomes to you. So on that part, we have to evaluate how it can be improve. As in the auto scaling part, we can simply understand that it needs to handle all kinds of traffic. Like whenever the traffic increases or decreases, it needs to scale it automatically. We do not have to do our any manual intervention. So on that part, we will be implementing the auto scaling part, that our model is or our solution is working finely, no matter what kind of traffic it is handling. So as in the experiment tracking, in this it is very essential that whenever we make a solution, either it is of ML or any normal traditional software solution, that we keep in check the all the experiments. Suppose you have been you have created a solution, a particular version has been released for the production, and somehow you have done some new changes, and now you are not getting a desired results. So in that case, you can track back your experiments. That particular experiment was working fine, and now this experiment is not. So we can keep in check that, yeah, which experiment I have to switch, and what was the mistakes or what are the improvements that we have done between them. So for that purpose, we need to keep in check our experiment tracks. As in the cost monitoring, now it is the major part of any solution, that whenever we use any kind of clusters or host our models or host our solution, it definitely uses some resources. So it is very essential that we have to optimize this cost, that whatever the solution, it is not causing any loss to the customers or to the business, that it affects their profits, or that it affects their solution to go down. So that is all the part that we can consider in the monitoring and the optimization part. So moving on, let's talk about achieving MLOps with the Azure ML. So before that, let's have a question that what if you have trained your model outside of Azure Studio Canvas? Let's say Azure provides you some of the models or some of the features that you can use, but you have some different idea. You want to train some different kind of model, and you still want to deploy it using the Azure. And what if you want to utilize some certain algorithms that you have written or you are utilizing apart from the Azure ML it provides? So in that case, still you want to use that particular service to be deployed to be useful to the customers. So in that case, still we need to identify is it suitable for us or not, and what about the REST endpoints. Let's say any application you want to create a REST endpoint that can be utilized by any user or integrated into any other application. So is it Azure ML suitable for all of these process? I would say yes. You can do all of these things in your Azure ML. Like if you want your Azure service, you want to deploy your model or any solution. It involves the Azure machine learning platform. It involves ACR, Azure Container Registry, which provides us the version control. It provides us storing our images, and over there we can create a particular app. That particular app is not only dependent upon the ML. That is your app that encapsulates, or that we can say that serves your the priced image using that particular Azure web app. So you can host it using this platform. So yeah, we will overall say that whatever the use cases, either Azure ML providers or not, we can simply use it to serve it at the global level. So moving on, let's talk about Azure Container Registry. In simple terms, it is just a Microsoft own hosting platform that it provides us to contain our images and for the related artifacts related to our solution. So it can be also a private registries that you can keep the security check over there. As in the ACR features, you can create a container registries in your subscription. Whatever the subscription you have taken, you can create a container registry based on their plan. There are basically three types of plans over there: the basic and the standard and the premium. It depends whatever the budget you have, you can opt between them. So you can use the standard logging command or the Azure CLI option. These are the steps for the setup. Like you have created a solution, now you want to integrate your Azure ML platform. So these are for using these methods, the Azure CLI steps. You can integrate those things. You can push your images over there, and the container ACR will be containing all your repository that you have pushed over there. And as in the each snapshot, it is stored over the container. Either it can be hosted using the Windows or the Linux. Whatever the environment that is suitable for your application, it can be included in the container registry. So you have the complete control over your images or stored over your container for the deployment part. So as in the ACR task is to basically it task to streamline the whole building, testing, pushing and deployment of the images. Like from end to end, you can leverage this ACR to serve your solution. So moving forward, now let's talk how you can actually deploy your model using the Azure. So Azure Web App is basically it is a fully managed platform that we have already discussed that it helps us in building a solution, it helps in scaling in the deploying part, and as the application itself as a web app, so it supports various programming languages. Like you are not limited to any particular language. Whatever the solution, whatever the language you are comfortable with, you can opt any of the languages. Like you can see here, it is supported with the many languages like .NET, Java, PHP, Python, Node.js, and there are more. So these are the features of the deploying part. Like we can serve our services of our simplified app deployment. As in scalability, it sounds understandable that it automatically scales apps and based on the demand. As in the CI/CD integration, it is seamlessly integration of a CI/CD pipeline for the automated deployment that we do not have to do any deployment or changes over the artifacts manually. We just simply have to commit the changes and the whole process will take into action. So moving forward, let's talk about the requirement. So whenever we are creating any solution, these are the major requirements, basic three requirements that you will be requiring for the ML part. Docker is first. So as we all know that we have to encapsulate our whole solution into a one thing. So for that, we will be requiring the Docker. And as for the creating the endpoint using for that will be utilizing our model for the prediction part, we can use the Flask. There are other alternatives also, like for the Flask, instead of Flask, that you can use Fast API or you can use the Django platform, Django framework. Whatever you are comfortable with, you can switch between them. As in the Azure CLI, so as to interact with the Azure platform, in your project you have to make sure that Azure CLI is installed and you can interact, or your credentials are defined in your environment, so you can interact with the Azure platform. So these three are basic requirements that you have to make sure before building any solution that will be integrating with your Azure. So moving forward, talking about this architecture, as we can see, the flow here, it comes like the source code or the solution whenever it is committed over a source control GitHub repository. When it is committed, it triggers a CI/CD pipeline. In this CI/CD pipeline, we have defined some steps, like as for the ML part, we can consider like fetch the data, do some pre-processing, now train your model, and after that validate your model. Is it meeting is it meeting the desired threshold or not? So based on that, it will be training your whole model. Once your model is completely trained, now it will be dockerizing that particular solution or the application into one thing, and then it pushes over the Azure Container Registry ACR. So once that Docker image is pushed over your ACR, now the finally Azure Web will be able to capture the pull that image from the ACR and deploy it over the Azure endpoint. So that's the whole architecture that we will be also seeing in a demo. So moving on. So how it works? So basically, in the pipeline definition, as you can see, it's a deployment process of a model is defined and managed to GitHub action. So in this, for the CI/CD action, like what we'll be using, we have applied the we are using the GitHub action. So when we do any commits or do any changes in the code and do a commit, so GitHub action will be taking the responsibility to build this whole process of build the image and push to the ACR or the Azure. So as in the component, as component involves the various part of like Docker containerization, as in services like we have Azure Container Registry. Obviously, it involves our whole process to be dependent upon the Azure Container Registry. So for that, it requires it, and for the deployment, it will be using the Azure Web. So it ensures that whenever a model is deployed, it also has the feature of the scalability and modularity. As in the independence, the each process that are doing, like we discussed the pre-process, model training, model validation, the deployment. So each process dependent upon its previous process. So once a previous process is completed, then only the next process will execute to ensure that our whole pipeline is executing step by step and it is working fine. So that is the dependency part over here. As in the efficiency, as we can see, the structured approach ensures that efficient execution and the resource utilization, proper utilization of a resource across the Azure platform, which it is currently using the leveraging GitHub action for the automation or the web app for Azure web app for its hosting. Now coming to the logging part. As in the logging, that whenever we create a solution, we have to ensure that logging is very essential. That there might be some issues occurring, or uh, either on the model part or on your code part. So whenever the logs are defined over there, you can directly monitor that whatever whatever the error is occurring and on which part. So based on that, you can directly debug. Yeah, particular error has been causing this issue over there. So I have to refactor it or correct it. So we have to make sure that whenever we make a solution, logging should be there to ensure that we do not kill our time over finding out what is the issue that we are facing. So that's all. And moving on with the benefits of the using GitHub Action. So as we can see, it is integrated. It helps in integration of the CI/CD, seamless integration with GitHub repositories, continuous improvement. We can improve our solution, do the enhancement part. As in the collaboration, we can work with our team to make the whole complete solution and facilitate your ideas. As in the direct Azure integration part, it do not require any complex method. You just simply have to authorize your Azure with the GitHub, and then you can it will be utilizing your GitHub actions directly and triggering your pipeline. As in the security part, GitHub secrets, it stores the secrets like the credentials, whatever the credentials you required to log in your Azure account. So it will be it will be providing you that security part that it won't be compromised. So as in the real-time monitoring, when the whole solution is served over the internet, now it comes to the monitoring part. It also provides us the workflow that you can monitor your performance of the model. You can monitor whatever the inputs or output it has been sending and whatever the traffic you have been received. So you can do that all using the GitHub action. So moving on, the best practices and recommendation whenever we create a solution, what are the best approaches that we have to keep in mind? So as in the consideration part, uh, let's say monitoring and the logging, as we have already discussed, we have to make sure that our solution is completely monitored and the logs are properly maintained. As in the security and compliance, that it provides us the say by the Azure that the control over the repositories or the ACRs that we are limited, that it is not public. So it ensures that our solution is not compromised. So the authorized user or the authorized developer can only access those and make changes. So as in the documentation and knowledge sharing part, that we can understand it on its own, that whatever the solution we make, that we have to keep it in docs. We have to keep check that our proper doc is maintained of a solution. So whenever you do any KT or any knowledge sharing, that you can refer those docs, or any other user that is working on your solution can have a thorough idea of the solution, that yeah, this particular process has been followed and this solution has been utilizing these services. So these all kinds of things should be mentioned over your documentation. As in the feedback loops and model iteration. Feedback loops are basically integrated that when your solution is served. So feedback loop is created that sometimes a data scientist or the data engineer uh, keeps in loop and check that model is performing well or not. So it makes some calls, makes either the true or false prediction. So based on those metrics, the prediction it is made, either it is true or false. It creates a particular metric, and the particular metrics helps the data engineer, the data scientist to identify that either they have to change their data sets or change their algorithm or do some other optimization or do some hyperparameter tuning in those solution to enhance their product. So as in the performance and optimization, as we can understand, it needs to be continuously optimized, that a model or the solution is properly maintained, it is it is enhanced. So as in the identity and the address performance part is a like uh, as in we can say identity and address performance, it bottlenecks using the vertex set. So it can also integrate your particular solution, particular management of your users or the authentication using this in the performance and optimization. So moving forward, let's say the demo. So talking about the demo part, let's first we will go through our code. So as we can see, this is a Python code. Basically, as in the application serving part, what we are doing over here, we are using the Flask application to create our endpoints. As in those endpoints, we are receiving some inputs from the user, and we are rendering our HTML page. So this is just for the demonstration purpose. So we as in the HTML code, we can just see that this is a simple code defining the some input fields. There is nothing much done over there. So it is just for the demonstration purpose. Now coming to the prediction part, what it takes the input field that has been provided to it. It does some pre-processing over there. It applies the prediction and the model and the data, as you can see over here. Uh, yeah. So as in components, we have some defined code like data ingestion, data transformation, model trainer. These are the helper functions that we are utilizing to do all the pre-processing or the data model training or the data transformation using this Python code. So this is totally depending upon the data set you are leveraging. It is not limited that you learn a particular logic of the pre-processing and you apply those on every data set. every data set has its own different feature. It has its own importance. So accordingly, you have to do some EDA over your data. Like we can see over there that we have done some EDA over this data as we opt for the student performance indicator, in which we will be identifying or we will be making a solution to identify the performance of the student. So as we can see, we have done our EDA over here. We have created some charts in this EDA. We have find out the how many NA are there, null positives are there. You can see over here, these are the techniques that we use before creating a solution. We perform our EDA first, then only we finalize that data is suitable and we will be creating a model. So that is for the programming part. Let's say how it will be triggering a Python. Now let's say I am making a minor change in my application. First I will walk you through my GitHub repository. Let's say refresh it. Now you can see the last commit. It is not recently, it was just your changes 2 hours ago. So now I want to make a particular change. Let's say I want to change some data set, I want to apply some different algorithm. We can do any changes over here, but for the demonstration purpose, what I will do, I will just apply some reformatting over here, nothing else. So my code is completely now, it will be detecting some changes. Let's say, yeah, it app is detecting some changes. So I will add my app. Now I will do new commit. I will commit like test commit Python. So now I will push it. Yeah, so my changes have been pushed. Let's verify. Yeah, test commit pipeline is present here. Now as we can see, GitHub action is already taken into place. That now we navigate into the actions over here. It is doing the deployment or doing the build part or the push part. It is processing it using the GitHub action. Now when we open this test commit pipeline, now we can see over here as in the build. If you open it, it is installing my requirements. So as we can see, set up a job run action, set up Docker build, login into registry, build and push container into registry. So it will be installing all the requirements that is required for my application. It will be pushing it over there. So once it is done, it will come to the deployment part. So as in the action we can see, I will just walk you through the another experiment that we have already created, because this process takes a little bit time because it is creating your solution from the scratch. So what happens when you build it successful, it will come to the deployment part. So as in the deployment part, it will be deploying your model over the Azure. So let's navigate. Yeah, test commit is still happening. So what happens when this particular deployment is successful? What happens in the Azure, we can see Azure, we can see we have created our registry. What this registry will be doing, it will be working as a source for our repositories. As in repositories, these are the images that contains our solution that is pushed by this GitHub action. So whenever this deployment part is completed, it puts a new repository with some Docker tag in it over here in the test demo registry. We can see it over the repositories. So when it is done, what we have created over here, we created a web app. So I will just walk you through how you can create a web app. As in web app, first you have to select your subscription. Like say I will select my MLT, whatever the name you want to give to your app. Like say I will say ML test application. So as in this, we have encapsulated our solution into an image. We will be opting for the container. Whatever the environment, either it is a Linux or Windows. So we will be opting the Linux, and in the region, in which region you want this resource to be created. So That's all, and we will create next. That we do not require for right now. As in the container, yeah, we have to select in the image source. Whatever the source of our solution, we have to opt for that. And in the registry, we can see in the registry we have test demo registry. In the test demo registry, we have our image. And in the image, we can see app in the app ML test and test demo HTML test, whatever the image that is containing your solution, you can opt for that. So let's say I will select the app. As in the tag, it will be picking up my latest tag from the image. And in the next, I do not have to do as I'm allowing the public access to it. And in the monitoring and secure part, I will keep it the defaults. And in the next, I will still keep it the defaults. So now my web application is configured and it has been provided with the source. Now I will click on create. So now it is submitting my deployment. It is creating my particular web application. Once this particular web application is deployed, it will give a view of resources. Yeah, so deployment is successful. Now if I click on the go to resources, so as in resources, we can see we have all the options here, the overview, diagnose and solve a problem. As in the deployment center, we can look for the logs or opt for other things, not just loading. We can apply a GitHub action, whatever the triggering pipeline we want to create using this source. So we will currently opt for GitHub actions. And this here, it requires some SCM setting to be enabled. Let's say enable it. So, so it is updated. Yeah, it is updated now. So my SCM setting has been installed. It is linked with the settings. So as we can see in the properties, we have the option of monitoring. We can create our dashboard. As we can see whatever the data in, data out, as we were discussing, request made, request time, and then in the logs, we can create a log stream. In the capabilities, we can identify what we can define whatever the feature, what are the capabilities of a solution. In the notification part, we can subscribe for any notification that either it is the metric related or model related. We can create a notification dashboard over there and we will be notified for that. This is the recommendation part. Resource, when the recommendation ML Azure and Microsoft Azure wants to get, it will be provided over here. So this is the web application. That's the overview. Now for to utilize the web application, it has created a default domain. So whenever we open this default domain, it will be opening my application that we have created. So if I click on it, it takes a little bit time. So for that purpose, we have already deployed a web application already. So as we can see here, the test ML app will iterate it or navigate it. So test ML app, it has been deployed already. So it is working now. So as in the test ML part, test ML app, it is deployed and we are currently using it. As you can see, the region status is running. We can also restart it from restart it. We have all the option of stop. Either you want to delete the app completely. So these are the options you can do for your web application, which is currently now serving a Docker image that has been pushed by the GitHub action. So you can see over here in the container image, it is giving us the path which image it is utilizing right now. So as in the test ML part, this is just a simple UI for the demonstration purpose. We have like welcome data over here. Yes. So that's how you do your end to build your end-to-end solution using the Microsoft Azure ML platform, where you encapsulate your whole solution into a particular Docker image, and then integrate your whole CI/CD using the GitHub action, and that GitHub is authorized by the Microsoft Azure to access it. So that whenever you make any commits, it will simply make any change or deploy your changes over the Azure and create an network. That's how ML part using the ML Microsoft Azure is done. And I hope that all of you have understand the agenda of this session, that how we can create an ML solution, how it differs from the normal software engineering and from apart from the ML parts, and how or what are the aspects or what are the things that you have to cover up in your whole solution, either in the marketing part or cost or the efficiency part. That is all about this session. So if you guys have any question and answer, please feel free to ask.
Guys, any questions? Are we having any questions? Okay, seems like there are no questions. So just to wrap up from here, thank you, Aman, and thank you, Ayush, for delivering this session. And I'll request each and every one of the attendees to fill the assessment form that will be surely rolling out just after this. Thank you for attending. Have a great day ahead, guys.